Hello friends, welcome to engineering tutorial. Now in the previous video we discussed some of the basic concepts related to nodal analysis with voltage sources. When we have a circuit and we are solving it using nodal analysis and we have independent or dependent voltage sources, whether they are connected in between node and ground or in between two nodes. So we discussed about the supernode concept and other related things. So here we are going to solve a circuit and try to determine the node voltages. So as you can see, we will be using the concept of supernode. Why? Because from this circuit we can see, let's say there are two nodes and we call it node 1 and node 2. In between node 1 and node 2 we have this independent voltage source, okay, 2 volt. So definitely here the concept of supernode will come into play. Okay. So from the concept of supernode we understood that when an independent or dependent voltage source is connected in between two nodes, okay, when a voltage source is connected in between two nodes, those two nodes combined together is called as the supernode. Those two nodes combined together form the supernode. Now here we have this 10 ohm resistor which is connected across the supernode. Now if I say this 10 ohm resistor has no role to play in this question, in this circuit, it contributes nothing, because if I say that the voltage between node 1 and 2, the voltage difference between node 1 and 2, let's say this is node 1, oh, this is not working, let's go with the black. Okay, let's say this is node 1. Here we have is the voltage source 2 volt. Here it is node 2. The voltage between node 1 and ground is V1. The voltage between node 2 and ground is V2. So if we apply KVL here in this path, it will be V1 plus 2 minus V2 is equal to 0, or V1 minus V2 is equal to minus 2. This is the auxiliary equation. V1 minus V2 is equal to minus 2 volt. This is the auxiliary equation. This relationship is very important. So what it means is that the voltage difference between node 1 and node 2 is minus 2 volt. Now if we have to apply KCL here, we will be only considering this two supernode. We don't have to consider the 10 ohm resistor, because no matter what current flows through this 10 ohm resistor, the net result will be like this. Okay, let me just erase this. I think you have understood this thing, that V1 minus V2 is equal to minus 2 volt. Now if I redraw this circuit, okay, if I redraw this circuit, let's say I node 1 and 2, I'm calling it the super node 1 and 2. Here we have a resistor 2 ohm, and here we have this resistance value is 4 ohm. Okay, I have missed it. Here it is 4 ohm. This is just for a simpler understanding. Okay, this is 4 ohm. Okay, the voltage here is V1, the voltage here is V2. This is 4 ohm. Now the voltage between 1 and 2, the node 1 and 2, V12 is equal to minus 2 volt. Now if a resistor 10 ohm is connected here, it makes no difference because the voltage across this resistor will also be minus 2 ohm. Okay, so it makes no difference. So the conclusion here is that a resistor connected across a super node makes no difference, contributes nothing to the circuit. So you can simply remove this resistor to avoid complications, to avoid confusion. Okay, now we have a independent current source here, which is 2 ampere, and we have another independent current source here, which is 7 ampere. Okay, so if we call this current, okay, current flowing here as I1, okay, if we call this current as I1 and this current flowing through 4 ohm is I2, then this is node 1, this is node 2, and this is node 1 2 combined, the super node. Okay, just for analysis here. Now if we apply KCL at this point and this point, okay, combining the super node, taking into the super node into consideration, you see that 2 ampere is entering the super node, it's flowing towards the super node. I1 is exiting, it is moving away from the super node. Similarly, 7 ampere and I2, they are moving away from the super node. Okay, 7 ampere and I2 are moving away from the super node. Okay, this is actually, okay, this is 2 minus I1, okay, and this is I2 plus 7. Okay, so 2 is the only current which is flowing towards the super node, and all the other currents are moving away from the super node. Okay, so the KCL equation will be 2 is equal to I1 plus I2 plus 7. Okay, 2 is equal to I1 plus I2 plus 7. This is the KCL equation. Now we have to bring it in terms of nodal voltages, because we have to determine nodal voltages. Now I can remove this because there is some lack of space, so we have to remove this. Okay, so let us just mark it here. This is I1 and this is I2. Now I have already explained it to you before that current always flows from a higher potential to a lower potential divided by the resistance involved. Okay, so here I1 is flowing from node 1 to ground. I1 is flowing from node 1 to ground. Don't think here is that why are you not considering the super node here. The super node is only, this concept is only used to make these two nodes as one node, but for applying the nodal equations, okay, the VH minus VL by R, you have to consider the single node. Okay, here we will consider only node 1 for determination of I1. No, the current I1 is flowing from node 1 to ground, so I1 will be V1 minus 0, the ground voltage is 0, by 2. Okay, I1 is V1 minus 0 by 2. Similarly, I2 is equal to, it is flowing from node 2 to ground, so it is V2, voltage at node 2, ground voltage by the resistance involved, which is 4. Okay, so we can write it here, 2 is is equal to V1 by 2 plus V2 by 4 plus 7. Okay, V1 by 2 plus V2 by 4 plus 7. Okay, so we can write it as V1 by 2 plus V2 by 4 is equal to 2 minus 7, which is minus 5. Or we can, if we multiply 4 on both sides, it will become 2V1 plus V2 is equal to minus 20. 2V1 plus V2 is equal to minus 20. Now, you remember the auxiliary equation, okay? The auxiliary equation that we just wrote it down. So that is, the auxiliary equation was V1 minus V2. The auxiliary equation is V1 minus V2 is equal to minus 2. V1 minus V2 is equal to minus 2. So this is one equation, this is one equation. There are two simultaneous equations. Now we can substitute one variable in place of the other in one of the equations and easily calculate. Okay, so let us do that. Let V1 is equal to V2 minus 2. V1 is equal to V2 minus 2. So if we substitute this here, it will become 2 into V2 minus 2 plus V2 is equal to minus 20. Okay, that implies 2V2 minus 4 plus V2 is equal to minus 20. That implies 3V2 is equal to minus 16. 3V2 is equal to minus 16. Okay, 3V2 is equal to minus 16. That implies V2 is equal to minus 16 by 3 volt. Okay, so if we calculate the absolute value, it would be 16 divided by 3, which is equal to minus 5.33 volt. Minus 5.33 volt. V2 is equal to minus 5.33 volt. Similarly, if we substitute this value here, V1 is equal to V2 minus 2. V1 is equal to V2 minus 2, which is equal to minus 5.33 minus 2, which is minus 7.33 volt. So V1 is equal to minus 7.33 volt. Okay, so if you have any confusion, this is the auxiliary equation. Okay, this is the auxiliary equation which we just derived by putting KVL between node 1 and 2, the supernode equation. Okay, V1 minus V2 is equal to minus 2. This is the auxiliary equation. This is one equation and this is one equation. These are two equations involving V1 and V2. So these are two equations, simultaneous equations of two variables V1 and V2. So we got the value of V1, which is equal to V2 minus 2 from this equation. We substitute this value of V1 in this equation. Okay, we got it in terms of V2. We found the value of V2, which was minus 5.33 volt. Then we substituted this value of V2 here and we got the value of V1. Okay, so it can look a little messy out here because of lack of space, but you please rewind the video wherever you don't understand anything. Okay, rewind the video, watch it again and again until you understand this whole thing in a better way. So here we have utilized the concept of supernode to solve this circuit and to determine the two nodal voltages. So an important conclusion to draw from this circuit, first one is that whenever there is a voltage source connected between two nodes, those two nodes combined together, they behave as a single node called a supernode, and the KCL equations are applied accordingly. The second important conclusion is that if there is a net circuit element, in this case it is a resistor which is connected in between across the supernode, across the supernode, then that resistor has no contribution to the circuit. You can simply remove the resistor to avoid any confusion. Those are the two important conclusions that you can draw. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.